Well, now that I'm learning how to use my ShopBot Desktop, I decided I need a nice sign out on the road to show folks who I am and what I do. Understanding the desktop is a very small footprint machine, only 24 inches wide by 18 inches high, I needed to design a sign that could be made in pieces. So here you see a sign that has my logo, and then under that it has panels that show the various things that I do in my shop, and it's all supported on a 4x4 pressure treated frame that I can sink into the ground, and the pieces all will hang from stainless steel hardware. And finally, this is made of high density urethane, which is impervious to the weather, can be painted, and make a sign that hopefully will last a long time. So here's the basic logo with letters that stand proud in a relieved textured background, and then I've got the four panels that are made the same way, raised letters with a relieved and textured background. For this outdoor sign, I'm using a high density urethane foam. This product is called Precision Board, and it's 1.5 inches thick, and it's 15 pounds per cubic foot. So a 4x8 sheet of this weighs about 60 pounds. So you can see it's comparable in weight to like a plywood. It's not like your regular building foam. It's much more stiff, and it's got kind of a granular composition to it that kind of rubs off on you. But it's impervious to water. It's closed cell, so that it'll last. It'll outlast the paint that I'm going to put on it. That's for sure. It'll last a long time, and so we're just going to go ahead and treat it like regular wood in the ShopBot. First, I'll be drilling 4 holes in the corners to secure this to the spoil board. Go ahead and mark the corners so I can drill into the spoil board. Where these little markings I made, these little grooves I cut every inch on the spoil board really pay off. It helps me make this line up quickly. Got to make sure I don't screw too hard into this stuff, because after all it is just foam, and the screws could easily just pull right on through. Just want it to be held down firmly so that the torque of the cutter bit doesn't move the material. Okay, the first tool to use is a 1/4 inch ball nose bit. And that'll do the roughing. And the reason I'm using a ball nose for the roughing is that I want to have a nice fillet against all the vertical portions of the sign. Any place that there's a vertical wall, I want to have a nice round fillet at the bottom. So I'll be using ball noses, even though for just clearance, straight bit might be a little more efficient, but a straight bit would not give me that nice fillet that I need everywhere there's a vertical wall. And I'll do a X and Y 0 using proximity switches, and that'll put my XY right at the corner down here where I want it to be. that zeros me in the X and Y. Go back to the keypad, get the bit in a position where I can zero the Z. Someone asked me in an online comment why sometimes I zero to the material surface and sometimes I zero to the spoil board surface. It really doesn't make a lot of difference if you really know the thickness of your material. But in general, if all your cutting is just going to be on the surface and you're not doing a through cut, I'm having trouble getting this clip on. Here we go. If you're not cutting all the way through with a cutout, then go ahead and zero on the surface of the material, because that's really where you want, any detail to be referenced from. If you're going to do a through cut, you can zero from the surface or the table. It doesn't matter, because you need to know the thickness of the material either way. And so measure the thickness of the material quickly and then decide where you're going to zero. I'm just zeroing on the surface. Obviously, with this case, I'm filling up the entire spoil board, so there's no place on the spoil board I could zero. Okay, so we're zeroed out in the X and the Y. One of the things to be careful with when you're using this thick of a material is to make sure that when your cutter comes to the safe Z height, it doesn't slam right up into the top stop of the carriage here, because if it does that, then your zero's off. The stepper motor will think that the carriage is in a different place than it really is. So just keep an eye on that. I learned from experience. Okay, I'm going to set my frequency to 200 hertz, or cycles per second, which equates to about 12,000 RPM cutter speed. That's a pretty decent cutter speed for this kind of work. I've loaded up my part, or I've got my part file on the computer. And first thing I want to do is I just want to double check that the zero positions are where I think they are. So I'm moving to the X, Y, and Z zero positions. And as long as it's at the corner there, I'm good to go. Alright, so let's go ahead and load up the part file. Is tool number 1 in the spindle? Yes. Is it zeroed on the Z axis? Yes. So let's go ahead and get started. Now let me just break here for just a minute to show you an animation of what the tool's going to do when it follows the various tool paths. Right now I cut the outline. There we go with the lettering, and then we're going to get into the texturing. There's texturing. That takes a while. And then finally, when the texturing is all done, we'll cut the profile outline with tabs, and then it'll be done. And then we'll return to the live video. stuff cuts easy, but boy, the dust sure gets everywhere. It's just kind of a granular kind of stuff. But anyway, we're cut all through, so I'll go ahead and take this off, and then we'll just break the tabs. There's 10 tabs holding this in place. They just break with a chisel very easily, and then we'll be ready to begin the finishing process. Here I'm cutting the individual signs that show the services that I provide. Each sign will be 23 inches long and 6 inches high. There'll be 4 of them. This one will say furniture repair. There's another that says custom furniture. There's another that says CNC carving, and the last one will show my phone number. Right now, the bit is doing the textured cuts in the field. That same bit was just used to do the rough out cut for the entire piece. It's a 1/4 inch ball nose bit. Once all the machining's done, all I've got to do is use a utility knife or a chisel to cut through the tabs. And then knife and carve off the tabs. This stuff cuts really easy. Now when I set this up, I set it up for the cut-through pass to go 5/1000ths into the table, and you might have seen a little bit of material that was remaining. That's just the inaccuracy of the setup. So I added 5/1000ths, but instead it did not go all the way through, but it went through enough. So sometimes you'll go into the spoil board a little bit, and sometimes you won't. High density urethane foam has to be primed before you paint it, and you really need a special primer, a very thick primer. When I bought this can, it was extremely thick. Watching the video on precisionboard.com, I could see that mine was too thick and that you can thin it. So I went ahead and thinned it down. It's still very thick. You can see it doesn't really drip well from the brush, but it's thick like that so that it can fill in the little pores that are all throughout this closed cell structure. So it's a water-based product, easy to use. Gets a little tough though when you're in the little letters trying to, prevent it from globbing up. But the idea is to put on a thick creamy coat, and then most likely a second thick creamy coat until you're all filled in, and there's no more of this dusting from the surface, which this stuff really does tend to dust, this HDU. The other thing that's important, according to the video, is to really let this dry well, because HDU is a closed cell structure. It won't absorb any of the moisture from the water-based paint. So it's all got to come out the surface of the paint, which is not like wood. In wood, the moisture can be drawn into the wood as well. So you really got to make sure that this is dry before you put a finish coat on top, or you'll see blistering and bubbling of the finish coat as the moisture continues to leave the primer. Now I'm using some alkyd enamel to paint these. Let me tell you, this is time consuming. I'm doing the second coat on these letters. There's got to be a better way, but I don't know what it is, other than just painstakingly painting. Now it's time to install the mounting hardware. I'm using these long stainless steel eye bolts. The total depth that these will sink into the material is 2 1/4 inches. Now, when you're working with high density urethane, what they tell you to do is drill a hole 1 1/2 times the diameter of the screw, and then drill it slightly deeper than the length of the screw, and then set it in epoxy. But because these are really long bolts, what I'm going to do is I'm going to drill down 1 3/4 inches. Remember I said the total purchase on this could be at 2 1/4. That leaves about a 1/2 inch or a little less where I can then drill a hole the size of the shank and actually screw it into the urethane, so when I put the epoxy in, the bolt will sit nice and vertical, perpendicular to the surface and not flop around any. And I'll still get plenty of epoxy along the length here. I spared you the misery of watching the matchup between myself and an epoxy spatula, but you can see I've got the hardware installed. The epoxy is supposed to be a stiff epoxy that can bond to the foam and to hold the metal in correctly. That's stainless steel hardware. I used S-hooks basically because they're less expensive than using an actual fitting that you can screw together. And in this shot you can see how the entire sign hangs. Right now I'm hanging it from the railing in my shop, but later on it will hang from the structure that I'll mount out near the road. So there you have it. That's my experience with high density urethane. It cuts nicely, it finishes nicely, it's very light, and we'll find out with time how it stands up to the weather here in Virginia.